Outdoor pollution is actually a major health risk, causing about 4.2 million deaths worldwide each year, and they contribute in fact to 8% of all deaths worldwide. And pollution like that comes from many different sources, and currently nation states, they are strengthening legislation in many different sectors on, for example, air quality. And this will drive in the nearest future, in the near future, in fact, requirements for better sensors, better sensor networks, and improved data handling. Holistic solution needs smart distribution networks of sensors and data handling sites. It needs community-based solutions, and it needs real-time monitoring and real-time warnings in case anything happens. The TRIAGE project was initiated and defined to assist with these requirements and provide really high technological solutions. This short video is just to provide the main building blocks of the project, and so if you need more info, we actually have a very good website, so I urge you to go and check the website. TRIAGE is building on an earlier project, FLARE, in which many of the consortium partners of TRIAGE were also together. And here we developed an airborne air quality monitoring system, quite successful with final test helicopter over ships. So in general, that was to monitor emission from ships. It has a lot of very nice videos, a main video on its website detailing the physics of the measurement principle here, and also of the final testing, helicopter-based testing. So I urge you to go on that homepage and check it out. TRIAGE will build on the experience and the results of FLARE, but we will extend it quite significantly. We will develop new and much more broadband sources, and that will allow us to detect many more different pollutants. We will also significantly increase the precision of the measurements, and we will introduce a large part of machine learning that will allow us to significantly improve the data handling and make it real time. The main hardware components of TRIAGE consist of 4 devices. First of all, we have the mid-infrared broadband laser, so-called supercontinuum source, that allows to cover many more pollutants than was ever done before. Then we have the multipass cell, which allows a very long interaction length between this mid-IR laser radiation and the air. And then we have a Fourier transform spectrometer that sort of splits the broad spectrum into its constituents, and it uses a set of balanced detectors to very accurately measure exactly how much of the different pollutants is in the air.
In addition to the hardware aspects, TRIAGE will use the latest big data and machine learning technology. They will help us understanding and analyzing the complex data sets that we will obtain from the spectroscopy of the multigas mixture. The infrared spectroscopic data can provide information on the different molecules that are present in the air sample. But calculating the contribution from an unknown mixture of different gases is an extremely challenging task. We are training the software on known gas spectra and deliberately adding noise and other errors to mimic real experimental measurements. We made good progress already in our test on real data, and we will be ready for the project demos experiment. The TRIAGE systems will be tested at sites in Sweden and Switzerland. They range from remote forest locations to the rooftop of public urban buildings. The system testing should begin early 2023. The TRIAGE.net is a group of organizations which includes national agencies and major companies. They will assist in the testing of the prototype and are already providing expert advice on use cases.
TRIAGE has established the European cluster of research projects for environmental and agri-food monitoring, so-called eCLEAN, which will and already has enabled significant collaboration across projects that are related. You can find much more information about the project on the project website, such as a description of the project, newsletters, links to scientific papers and upcoming events. And there's also a mailing list, so if you're interested in the project, then please go on our project website and register, or send us an email so that we can put you on the list.